one of the design class A power amplifier. We designed a common emitter BJT class A power amplifier with an emitter resistor and bypass capacitor. Since we are using 2N3904 NPN transistor, the maximum value for VCEQ from the on-semiconductor datasheet is equal to 14 volt. And from calculation, we got the value of ICQ which is lower than 10 milliampere. Therefore, the value of beta is 100. Okay, based on this configuration, we can find the value of VB using the Bennett equivalent equation. And from VB, we can get value of IE which is equivalent to ICQ. From this value, we obtain the percentage of efficiency that is 25.5. Is verified for our main objective efficiency that require us to design class A power amplifier which efficiency between 35% to 15%.
This is our DC analysis circuit in multisim. This is our VB. Our VB we get 2.424 volt. This is our VBE. For the VBE we get 719.596 millivolt. This is our VCEQ. For the VCEQ, we get 5.593 volt. This is our VE. For the VE, we get 1.705 volt. And lastly, this is our ICQ. For the ICQ, we get 7.70 milliampere. This is our real circuit with RL 22 kilo ohm and VRMS 1.5 VRMS with 60 Hz of frequency. And this is our DC analysis. For the DC analysis, the capacitor pin opened in open circuit, so there's no VRMS and V in and the other component here. Okay, for the AC analysis, the channel B is our output and channel A is our input. So this is our signal. You can see with the same scales, the output amplify. The output is greater than the input with value 7.671 volt. This is our PCB board. This is our VCC pin, our V-in pin, our VR pin, and also ground pin. For the VCC pin, we set the pin to 15 volt, V-in 1.5 VRMS with 60 Hz, and we chose the RS to 1 kilo ohm, RB1 10 kilo ohm, RB2 2 kilo ohm, RC to 1 kilo ohm, RE 220 ohm, and also RL 22 kilo ohm. For the capacitance value, we chose the 3 capacitance value with 1 microfarad. This is our transistor. For the transistor, we chose 2N3904 NPN transistor. We use the on-semiconductor datasheet. For the pin, this is the emitter pin. The middle one is the base pin, and the lower one is the collector pin. For the VCE, we use the maximum rating for the VCE is 40 volt. When calculating, we get the value for the ICQ lower than 10 milli ampere. Therefore, we choose the beta for the 2N3904 set to minimum 100 till 300.
Now we're gonna test the result for implementation hardware part after we got all the value that we need from the hardware such as VE, VB, VCEQ, and ICQ. We're going to compare it with the value of theoretical and simulation. We are using a PCB board and the component has been soldered. As we know, the measurement of the ICQ need to be in series, while the measurement of voltage need to be in parallel. Now we're going to start measuring all the value that we need. To measure for DC analysis, do not connect anything across V in and V out. We apply a DC voltage of 15 volt using a DC power supply. To measure VE, we're going to connect the red probe of a multimeter to the point between emitter pin of RE and its black probe to 0 voltage. The value for VE is 1.69 volt. The same method we applied for VB and VCEQ. The value for VB is 2.40 volt. And the value of VCEQ is 5.81 volt. To measure for ICQ, disconnect DC voltage from VCC pin, connect the DC voltage to the red probe of multimeter and black probe to the RC pin. The value for ICQ is 8.87 milliampere. For AC analysis, we connect the channel 1 of oscilloscope across V in, which is the input of the circuit, while the channel 2, which is the output of the circuit, across V out. We apply a AC sinusoidal voltage at V in, which is 4.3 V peak to peak, and 60 Hz for frequency using a function generator. And finally, we can see the value of V in 4.3 volt and V out 7.6 volt from the signal of the oscilloscope. From that value, V out, which is green one, is amplified.
Based on the theoreticals and simulation result, we obtain the efficiency almost but not quite close with each other. The result obtained from the theoretical is 25.6%, while the output voltage value from multisim gives the value of power output by using the power output equation, and it gives the efficiency that is 25.75%. For the practical, the value of efficiency is 24.55%. It was obtained by using the equation, and we use the value of the output voltage from the oscilloscope to obtain the power output. We using the equation V out squared over 2RL. Our class A power amplifier efficiency is between 25% to 50%. Therefore, we did